Hi there, welcome. This is Dramani Online Mathematics, and you are welcome. Please do your best to subscribe to my YouTube channel and share to your colleagues so that they can all enjoy. This selective math, we are looking at limit of a function. We are at limit at infinity. All that we have done so far is limit at a point where the limiting value will be given to you, whether x approaches 1 or -1 or x approaches 0 or any number at all. But in this case, limit at infinity talks about where we don't know the number that the x is approaching to or the limiting value is approaching to. So we use the infinity sign to represent it. Okay, all right. Now that we know this, what are we going to talk about? Or how do we solve this limit at infinity? If you want to solve limit at infinity, the first thing to do is to check the denominator. That's the first thing to do. Don't look at the numerator, the denominator. The denominator is the number at the down here. Is that okay? Secondly, look at the x, the highest power of the x. The highest power of the x. So in this case, if I look at the denominator, I have only one x, and that one is power 1. So what I'm saying is that assuming that here was, let's say, I have x squared plus x or 2x. But we are considering the powers, okay? You realize that this is x squared, this is x power 1. So which one is having the highest power? The x squared. So here we have only one x, but I'm trying to demonstrate this thing to you to know that if, assuming that this one was the question, then we would have picked the x squared ahead of the x power 1. So we always consider the highest power. The highest power. Is that okay? Good. For understanding. After considering the highest power, this is what you are going to do. You are going to divide each by the highest power that you pick. So if here we picked only x, means that I'm going to divide here by x, here by x, here by x, each term of them. So let's see how we go about it. So I have the limits as x approaches infinity of 3x over x plus 2. So now that you have seen that the highest power is x, what I'm going to do is I'm going to start dividing. So I'm going to have 3 to the power x, 3x over x, all divided by x over x, 2 over x. So each term will be divided by the highest power of x that we picked. Is that okay? Good. Now you realize that this one will cancel this. This x. Now you realize that this one will cancel this. This x can go into a of 1. Is that okay? This x can go into a of 1. So when you have something like this, you are going to have the limit as x approaches infinity, 3 over 1 plus 2 over x. Now, the only x that we have is this one. So what you are going to do is that you are going to substitute the infinity sign there. Is that okay? So this is what I'm going to have. I have the limit as x approaches infinity. Once you start doing the substitution, please do not bring the limit again. So 3 over 1 plus 2 over. So here I'm going to replace it by infinity. Now, what is happening here? The infinity means that we don't even know the number. The number is bigger or larger. You understand? And look, let's say if I have 2 over 100, it is the same as 0.02. What if I have 2 over 1 million? Then I'm going to have 0.000002. So you see that the more you increase this number, the denominator, the number there, the more you approach towards 0. Because here, if I ask you to run this one to the nearest to 2 decimal places, you see that I get 0.00, 3 decimal 0.0. So when the denominator keeps on increasing, then what happens? The number will be approaching what? 0. So we say that 2 over the infinity is 0. So 2 over, or any number over infinity will give you 0. I hope it is clear. Very good. So here, what it means is that this place I'm going to have 3 over 1 plus 0. So 2 over the infinity will give you 0, which is 3 over 1. And 3 over 1 is what? 3. I hope it's okay. Very good. Now let's move to another example. Yes, so this example 2, where the question is saying that you should find the limit as x approaches what? Infinity of x squared plus 1 all divided by 3x cubed minus 4x plus 5. So here you have to find the limit at infinity. Remember that. So at infinity, I've already explained the rule to you. The first thing is that make sure that you look at the denominator. After looking at the denominator, don't even look at the numerator, After looking at the denominator, the second thing to look at is that the highest power of x there, or highest degree. So looking at this, here is x to the power 1, here is x to the power 3. So which one is with the highest degree? Is x to the power 3. After getting that, the third thing to do is that you divide through that highest, the one with the highest power 3, through with the numerator and the denominator and with each term. So that's what we are going to do here. So I'm going to have the limits as x approaches infinity. So I'm going to divide each term by x to the power 3. So that will be x squared over x to the power 3 plus 1 over x to the power 3 all divided by 3x cubed x to the power 3 minus 4x x to the power 3 plus 5 over x to the power 3. Have you seen it? So first you check the denominator, the highest power, then you divide through. Okay, after that, you realize that x approaching infinity, this x can go into itself 1 and go here x times. So we have 1 over x plus 1 over x cubed all divided by x going to itself 1, leaving only 3 here, minus 4 over what? X squared plus 5 over x cubed. So that's what you are going to get at the end of it. So what are we going to do? After getting this, you're now going to put the infinity sign there. So wherever you see x, you put infinity, 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 infinity. Is that okay? So here, so if I start doing the substitution, I don't need to bring the limit again. So I have 1 over infinity plus 1 over infinity cubed all divided by 3 minus 4 over infinity squared plus 5 over infinity cubed. And what will be the answer? The answer will be 0 because 1 over infinity will be 0. I have already informed you in the first example that if we divide anything by infinity, the answer becomes 0 because the more the number becomes bigger at the denominator there, the more you approach to 0. So we assume that it becomes 0. So here will be 0, 0, 0, 0. So at the end, the top here, we are going to have 0 here. And then down, we are going to have 3. Because all this will be 0. And this will give you 0. Because 0 over any non-zero number is 0. Is that okay? But 0 over 0 is indeterminate. That is not 0. Is that okay? Take note of that. So this is the answer to the example 2. Now let's look at our third example. Okay, so now let's look at this example 2. Example 3. That's our final example. The rest you can look for more example and solve it. Try to also subscribe to your colleagues. Okay. Find the limit as x approaches infinity of x cubed plus 1 all divided by 3x cubed minus 4x plus 5. So that is the question given. So first thing that we are going to look at is the same approach. So I'm starting straight. As x approaches infinity, the limits as x approaches infinity. So here you realize that the denominator, the highest there is x to the power 3. So you divide through. So here will be x power 3 all divided by x power 3. 1 over x power 3 all divided by 3x cubed over x power 3 minus 4x over x power 3 plus 5 over x power 3. Then after that, this go into itself, you have as x approaches infinity, 1 plus 1 over x cubed, all divided by 3, because x cubed will go into itself, minus 4 over x squared plus 5 over x cubed. Is that okay? So in this case, we are now going to put the infinity sign here. And if we do so, the limit will not come again. So have 1 plus 1 over infinity cube, all divided by 3 minus 4 over infinity squared plus 5 over infinity cube. 1 plus infinity cube, 1 over infinity cube will be what? 0. So that gives you 1 plus 0, all divided by 3 minus 0 plus 0. And that gives us 1 over 3. Is that okay? Very good. Now let's look at our final example, topic under the limit. Then you will start with differentiation. Is that okay? Differentiation. Thank you.